Good morning. My name is Alan Hammersmith, and I am an instructor with the Educational Services Department based out of the Boston Regional Office in Massachusetts. Joining me today is Satya Prasad, who works with the SDK unit on the Support Services team here in Redlands. We want to welcome all of you to today's live training seminar on building applications with ArcGIS Server using the Java platform. Today, we'll be discussing the different methods we can use to quickly and easily build web applications using ArcGIS Server. We will see how we can use the existing out-of-the-box application, as well as how to build our own application using available templates along with some of the pre-built controls. Then we will see how we can extend our application by adding in our own functionality by using the task framework, as well as how to handle results returned to the user. After each section, I will do a short demonstration to illustrate the topics we've just discussed. After each demo, we'll have some time to answer any questions that you may have submitted during the presentation. So let's first see what our options are for building Java web applications. By using the Web Application Developer Framework, or ADF, that comes with ArcGIS Server, we have three main options for quickly building our mapping applications. The easiest way to build and deploy a web mapping application is by using the wizard interface provided by ArcGIS Server Manager. The Web ADF also provides us with a web mapping application template that can be integrated into third-party development environments and customized from within these environments. The third option for building web-based mapping applications is by using the pre-built Web ADF controls, which enable you to incorporate GIS functionality into your own custom applications. Before we explore these three options in more detail, I'd like to take some time to explain exactly what the Web ADF is. That way, we may better understand how these options fit into the overall development framework. The Web ADF is a software development kit that consists of a set of controls, tasks, and applications that we as developers can use to create our GIS applications. The ADF enables us to rapidly develop our GIS applications, as a lot of the work has already been done for us. So what exactly is included in the Web ADF? First of all, we get ArcGIS Server Manager. ArcGIS Server Manager is a web-based administration tool that we use to manage our ArcGIS Server instance. Since it is a browser application, we can administer the server remotely without having to physically be on the server or install anything special on our desktops other than a browser. The ADF also comes with a set of pre-built web controls that contain common GIS components such as maps, toolbars, and table of contents. You also get a template that makes it very easy to create and customize your web application from within your development environment. The developer APIs are what enable you to develop your own applications. There are server libraries for your server application development, and also JavaScript libraries that allow you to perform client-side processing within your application. Several samples are also included as part of the installation and are also available on the EDN website. These give you a good starting point for creating your own GIS web applications. And of course, there's a set of documentation that will give you the reference materials you need to write your code. These can be found on EDN as well. Now that we have a better idea of what the Web ADF is, let's see how we can use these components to build our applications. As I mentioned earlier, the easiest way to build our web mapping application is by using ArcGIS Server Manager. This web application is installed with ArcGIS Server out of the box, so there's nothing special you have to do to set it up. It is one of the primary tools that enables us to administer our site. On the Services tab, we have the ability to create various GIS services, such as map and geoprocessing services, as well as control the settings for these services. Under the Applications tab, we can build, deploy, and modify our web mapping applications. We can also control the configuration options for the instance found under the GIS Server tab, where we will also find a tool for querying our services log files. So by using Manager, we can use the Create Web Application wizard to create the standard web mapping application. By using this option, it doesn't require any programming, as all the required information is filled in through the wizard. Here we can see the first screen of the wizard where it is asking us to provide a name for our web application. Then the wizard prompts us for the map services that will be used by this application. As you can see from the dialog here, we have the ability to incorporate several map services within a single application, and they can come from a variety of sources. These sources may be hosted on your server or remotely accessed through the internet on another server. The types of services you can use can come from ArcGIS Server, ArcIMS, ArcWeb Services, or WMS services based on the OGC standards. In addition to map services, we can also incorporate additional functionality into our application by adding in tasks. You can see the out-of-the-box tasks which are available to use, such as the search attributes, find address, and geoprocessing tasks. Some of these tasks require additional services, such as geocoding or geoprocessing services. The wizard also lets us choose what map elements are included in the application, such as overview maps, north arrows, and it also lets us control the look and feel of these elements. Once we've provided all the information the wizard needs, we can then deploy it to our server. There's also an option to export the application as a WAR file. Here we can see the final application. Notice the panels on the left, which provide us with various items such as the overview map and map contents and results from any queries we may perform. Once you've created this application, you can then customize the source files to give it the look and feel you desire. Another way to build your web mapping application is to use the template that gets installed with your Integrated Development Environment, or IDE. The look and feel of this application is identical to the application that is created through Manager, since the template provides the same files that are generated through Manager. While you can use any IDE that supports the JSF 1.1 implementation, we currently support two IDEs, Eclipse and Sun's Java Studio Creator, both of which are freely downloadable. We've created specific plugins for these IDEs, which are tightly integrated with the ADF. This will enable you to use the web mapping application template, ADF controls, sample applications, and easy access to the documentation, all within your IDE. The third way we can use the web ADF to build our applications is by using the pre-built controls. These controls are standard JSF controls, so if you have experience using JSF, this will be very familiar to you. What these controls do for us is expose the JS server's functionality to the client. Now the client has a way to leverage the power of the server by using lightweight client components. There are several types of controls that we can use within our application. The most commonly used control is probably the map control. This is the control that displays the map service to the user. There's also an overview map control, which serves as a reference point for your main map control. There's also a table of contents control, also called the TOC. This displays the list of layers that we see in our map control. It provides us with the ability to turn layers or even entire services on or off. It also contains the rendering information for our layers, so it also serves as the legend for your application. The most important control is actually a non-visual control called the context control. The context control establishes a working environment with the GIS server by establishing and maintaining a connection to the GIS services. It also manages any stateful changes that occur to other controls, such as turning a layer on in the table of contents control, which will in turn update the map control. This communication is managed by the context control. The task control doesn't actually have a standard component that it's associated with. This control acts more like a container for any custom functionality that you want to include in your application. Now I will demonstrate the standard web mapping application as well as a simple JSF application built using the web ADF controls. So here we can see ArcGIS Server Manager. I'm going to log in here. And here we can see I'm logged into ArcGIS Server Manager, and with all the tabs that I mentioned before up at the top. So here we can see the services tab, and I have two services running right now, one called California and one called San Francisco. This California service is the one that I'm going to be using throughout the rest of the demo. If I look at my Applications tab, I can see I've created an application called Demo App. This Demo App was created using the Create Web Application wizard, and you can see the link here under the Applications tab. I can also expand this tree structure, and I can see the application that was created. So if I click this link, here I'm going to open up this application in a new browser window. And here we can see that the California service is the service that's associated with this application. So I have the map control over here on the right, displaying my main map, and I have an overview map on the left, which shows where exactly I am in my main map. So these controls get associated with each other automatically. You can also see my map contents. So I can see I have several layers in my map, some of which are turned on, some of which are off. I also have some scale-dependent layers, earthquake history, and cities, which aren't turned on right now because I'm not zoomed in far enough. So if I zoom in on my map, then I can actually see that those layers will turn on automatically for me. And I can also expand these contents to see the rendering information of those layers. I've also configured a task for this application against my earthquakes layer, as we can see here with the green dots. So when I click on this task, it opens up this task for me, and I'm searching my earthquakes layer for earthquakes which have a magnitude greater than a number that I specify. Here I've specified 7.5, so I want to see the really large earthquakes that have happened. So when I click the Find button, it gives me the results, and now I can see all of the earthquakes which satisfy that result. Clicking on one of these will expand the result details here in the Result Details panel, and I can get some more information about that earthquake. I can also use these to zoom into, or if I click the highlight, it'll actually show me exactly where that is, and I can also click the clear highlight to take it away. This is some of the standard functionality that gets provided for you with the out-of-the-box web mapping application. Now I'd like to show you an application that I built using the web mapping application template here inside of Eclipse. So here I have this demo application, which was built using the web mapping application template. The files you see here will look just like the files that are created from Manager, with one exception of this map.jsp file. This map.jsp file is a file that I've created that I'm going to use. I want to create a very simple application using only the controls. So if we take a look at this JSP file, we can see the tag libraries I'm referencing up at the top, which enable me to use these controls. Like I mentioned before, we have to have that context control. This is one of the most important controls in my application. And I scroll down, I see I have a task control, which is configured to use the map tools task. So this will give me all my navigation tools. I have results table of contents, which won't show anything because I haven't done any results. And I also have a map control, and this map control has an ID of map1. So if I deploy this application, I can do so through Eclipse by going to my Run on Server option. And then this will open up in a new window within a browser that is built into Eclipse. If I wanted to, I could have also chose to open it up in Firefox or Internet Explorer. But for this, I'm just going to use the built-in browser within Eclipse. And as we can see, I just have those two controls. My map task control up here on the left with all my navigation tools, and my map control on the right. So the nice thing about these controls is a lot of functionality is already built in for you. So the map control here, if I use my mouse wheel and scroll the wheel up, it automatically zooms in for me. Right? I didn't have to code anything special for that. All I had to do was include that map control. So what I'd like to do is I'd like to include a table of contents below my map tools task over here. I like to be able to see exactly what layers I have and the rendering information associated with that. All right, so I come back to my code, and in my map.jsp file, all I have to do is add a table of contents control. So when I do that, I reference that tag library, which I've defined at the top. And then here I see all of the I have access to all of the different controls which are available for me to use. The one I want is the table of contents control. So I add that control into my application, and using the IntelliSense built within Eclipse using control space, I can see all of the necessary attributes that I need for this control. And we can see it has two required attributes of map ID and value. There are a few other attributes, but those aren't required. So if you wanted to customize the control even more, you can use those. So I have to give it a map ID attribute. And the map ID is I want to associate with my existing map control. So if I scroll down, I can see that my map control down here has an ID of map1. So what I have to do up here is provide that map1 ID. The reason I need to do this is because I could potentially have multiple map controls in my application. So I need to tell this table of contents control which map it's associated with. And as we also saw, I also need to have a value attribute, right? And this value attribute needs to use a value binding expression which will map to one of my managed beans, which have already been created in the template for me in one of my configuration files. And we'll take a look at that a little later on. So all I have to do is reference this object here, which is already part of the ADF. So now when I save this, now I can redeploy my application. It'll again open up in a new window, and now I should see on the left-hand side, I should see my table of contents control, which will have the listing of all the layers and also the ability to turn them on and off. And just like the out-of-the-box application, you can see that any scale-dependent layers get grayed out. And I can also use my scroll wheel to zoom in, and so that then those layers will then turn on. So I can expand these to see the associated rendering information, or even turn them off if I want to. So a lot of this is already built in for me to these controls, so there's nothing special that I had to code. All I had to do was include that control in my application. So if you're wondering what other controls I might be able to use, I can access that from the help menu, which also got installed inside of Eclipse. So inside of Eclipse, with the plugin, you'll get this ArcGIS item down here. So I expand this out for ArcGIS Server. We'll see there's an option for the reference down here for the web ADF. And then there is the option here for my web control tag library. So if I click on that, I can see all of the tags which are available for me to use for all the different controls. So if I look at that table of contents control that I just added, we can again see that I have the value attribute and the map ID, which are two of the required parameters. So in review, we've just discussed 3 ways in which we can quickly build GIS applications on the web. ArcGIS Server Manager and the Web ADF template both provide us with the standard web mapping application. We also have the ability to use the Web ADF controls, which give us more flexibility on the look and feel of our application. Now on to some questions with Satya.
Thank you, Alan. We do have a lot of questions lined up. I'll try to answer best I can. So first question is from Mike from Long Beach. The question is, where can we find support for how to install and configure ArcGIS Server with the Eclipse software? Mike, to answer your question, you can find detailed documentation, including screenshots on how to configure the ArcGIS Java ADF plugin with Eclipse and the Sun Java Studio Creator on our EDN website, that is edn.esri.com. You can find that under the Developing ArcGIS Server Applications option under the Getting Started. It has got 2 guides, one for Eclipse IDE and the other for Sun Java Creator IDE. So moving to the next question, it's from Vicky from Boise. And the question is, what is the context control? As shown in the slide earlier, context control is a non-visual control which is required for the web mapping application. The context control is basically a container for other web controls which help the other web controls to react to certain events. So we use the context control to update the other controls which is present on the page. And also, the context control is primarily responsible for making connections to the different GIS resources in your web mapping application. For example, if you have two GIS resources, one from an ArcGIS service and the other from an ArcIMS service, then the context control is responsible for making connection to both of those resources. So the next question is from Don from Salt Lake City. The question is, we have currently installed ArcGIS Server .NET on our machine. So can we also install ArcGIS Server Java, the web ADF, on the same existing machine? To answer your question, Don, the answer is yes. You can install both ArcGIS Server .NET Web ADF and ArcGIS Server Java Web ADF on the same machine. And if you happen to have ArcGIS Server installed on the same machine, both the ADFs will make use of the same ArcGIS Server instance. So the next question is from Eric from Oklahoma City. The question is Eclipse the best IDE used for developing applications in ArcGIS Server 9.2 using the Java Web ADF? To answer your question, Eric, we at ESRI do not recommend any particular IDE. However, from what we have seen, we see that Eclipse is one of the most adopted IDEs among the Java developers. And also, if you're using either Eclipse or Sun Java Studio Creator, we give you tight integration with the Web ADF, which means that we give you plugins which can be integrated into the IDE, which will give you the help, the samples, the web mapping application template, and the controls to be installed inside of the IDE. Cindy from Shreveport has got a question on, can I develop web applications using the WSDL file? Let me rephrase the question. The question is, can I develop a web application using the web service endpoints exposed by ArcGIS Server? The answer to that question is yes. You can develop web applications which directly consume the SOAP endpoints, and to help you do that, the ArcGIS Server Java ADF comes with a full-fledged SOAP API. So you could use this API, which is a part of the Web ADF, to develop your own web applications which talks to the ArcGIS Server behind the scenes using the SOAP protocol. Moving out to the next question. The question is from Jesse from Arlington. The question is, are there any code snippets provided with the Server Java platform? To answer your question, Jesse, if you're using Eclipse or Creator, and if you use the plugin to tightly integrate the Web ADF within the IDE, there are code snippets provided to add these controls into the page. However, the code snippets that you're seeing in the demos showed earlier have been built for the demo. It is extremely easy to build a code snippet for reuse using the IDE. Back to Alan.
Thank you, Satya. Now that we've taken a look at some of the standard functionality exposed in the web mapping application, let's take a look at how we can get our own custom functionality incorporated into the application. Adding in custom functionality is done by what we call a task. Web ADF tasks are objects that encapsulate the business logic of our desired functionality. These tasks can be configured directly through Manager, as I described in the last section, or it can also be done through the IDE. There are several available tasks that you can use in your application. The Map Tools task shown here provides us with the basic navigation tools that we need to use the map control. The Search Attributes task allows the user to search the attribute data of our layers for the specified search string. The Find Address or Geocoding task exposes address search functionality, so the user can type in an address to find it on the map. This task requires that you have access to a geocoding service. This could be one you're hosting yourself on your server, or one out on the internet, such as an ArcWeb geocoding service. The Editing task gives your users the ability to make edits to SDE data using only a web browser. Both versioned and non-versioned edits are permitted in this task, so you can easily integrate web clients into your overall editing workflow. The geoprocessing task is a customizable task that gives your user the ability to run Arc Toolbox models or scripts that have been published as geoprocessing services. If we want to do something that is not available in any of the out-of-the-box tasks, then we can use the task framework to create our own task. This framework exposes a way to add in our own custom functionality. The task we create can have three main types of components. They can have parameters, which allow the user to provide input to our task. They can also have commands, or also known as buttons, which will execute some custom code when the user clicks on it. And we can also include tools in our task, which will allow the user to interact with the map in some specific way. So why do we want to use the task framework? Well, the task framework is tightly integrated with the ADF. As such, when you're developing your custom functionality, the user interface is built for you. Also, all of the event handling of commands or tools is also handled for you. You just have to write whatever code in order to respond to those events. The task framework also allows you to organize your related functionality. In this way, you can group related tools and commands with each other and isolate those that are not related. If you've done any Java Bean development in the past, this process will be familiar to you, as the development cycle is similar to implementing a standard Java Bean. So let's take a look at these steps. The first step we take when developing our custom task is to create a standard Java class. This Java class will contain all the variables and methods we need in order to perform our specialized functionality. The variable and method signatures will determine the inputs your user will see when using your task. Here I've created my Java class and I've called it custom task. Once we've written our code, we need to register our class as a managed bean. Registering a class as a managed bean is done in the facesconfig XML file, which is a standard part of JSF development. Here I've created a managed bean called custom task, which points to the custom task class I've created in step 1. Now, I could have given my managed bean name anything I wanted to, but I prefer to give it the same name as the class, just so I know exactly which class it's pointing to when I use this particular bean. Once I've created my managed bean in the facesconfig XML file, I can now reference this by using a task control in my JSP page. Notice in my task control, I've used a value binding expression assigning my managed bean name to the value attribute of my task control. Once I run my application, I can now see my task exposed to me in the user interface. So when I'm writing my code, I can declare several types of variables in my Java class. The name and type of variable I create will determine how it displays on the user interface. In this example, I've declared a name variable of type string. When this displays in the UI, I can see the text box displays with a label of name, the same name as my variable. The same thing is true for this buffer distance variable, which is of type double. In this case, I've initialized this variable with a value of 40. So when the UI gets displayed to the user, 40 is used as the default value. Notice the label gets split based on the camel case syntax of my variable name. Since my variable is called buffer distance with the D capitalized, the label will display as two words as shown at the right. If I declare a variable as a Boolean, that will create a checkbox, which correlates to the true-false values of my variable. Since I've initialized this Boolean as true, the checkbox is checked by default. You must also provide the getter and setter methods as a standard in Java Bean development. You may want to put in some attribute validation such that your getBufferDistance method checks to make sure the user didn't type any non-numeric values. If we want to create a command on our user interface, then all we have to do is to declare a method that takes a task event as an argument. When the user clicks this command, the code within the method we've written will then get executed. The same is true for any tools we want to create, except all we have to do is declare this method to take a map event as its only argument, as opposed to a task event. When the user uses this tool with the map, this method will then get called. How does all this happen? What actually determines the GUI layout is based on the class's associated task info class. Every class you write will require a corresponding task info class. The web ADF automatically builds this class for you, but if you'd like to gain more control over how the GUI gets displayed, then you have the option of providing your own task info class. What this task info class contains is the metadata of all the task elements that you defined in your Java class. There's a class introspector that is part of the web ADF that reads your task class and cleans the metadata about your task. Based on the variable and signature methods you've defined in your class, the introspector will discover the parameters, tools, and commands that you've defined for your task. So the way this works is you start off with your task class, your Java class, which contains all of your custom code. The class introspector reads the Java code in the task class and will glean the metadata to discover all the parameters, tools, and commands that you've declared. Then it creates the associated task class task info class for you based on that metadata. Right, now we have everything we need to create our actual task control, which can then be integrated into our JSP application. Now I'll show you how to develop your own custom task by writing a standard Java class and incorporating into the web application I showed you earlier. So here I can open up Eclipse. I'm going to shut a few things down. And so first thing I've mentioned we need to do is to create our own standard Java class. So I can do this right within Eclipse. I can right-click my project, go to the New menu, and say New Class. So then in my new Java class dialog, I give it a package. In this case, it's going to be com.demo. And then I give it a name of Quake Task. Because this task is going to be used to query my earthquakes layer and get some information about that earthquakes layer. So when I click Finish on this dialog, you can see it creates a new Quake Task class, a Quake Task class for me within the package of com.demo. So the first thing I need to do is I need to declare a few variables, which I'm going to use to set a max magnitude and a minimum magnitude based on, so I can filter just those, quakes in my layer. As I mentioned before, as a standard in Java bean development, I need to provide the getters and setters. Now, I apologize for this being a little bit off your screen, but Eclipse does provide me with this generate getters and setters method, which will then go through and generate my getter and setter methods. And here I can see them. They got created for me. Get max magnitude, set max magnitude. Get min magnitude, and set min magnitude. So these are my getter and setter methods for these two double variables, which I've just created. So the next thing I want to do is I want to create a command which will take these two variables and filter and highlight the features on the map which fall between those two ranges. So I've created a code snippet to do this for you. I'll walk you through the code. So here I have this show quakes method, and notice here it takes a task event. So we know it's already going to be a command because it's accepting this task event as its argument. You also notice all of these classes have been underlined in red because I haven't imported them yet. Fortunately, Eclipse gives me a nice interface to do this for me. And here, now, when I'm using that Control-Shift-O syntax, I can see that all those appropriate classes have now been imported into my class. So if I take a look at what this class is doing here, I can see using this event that gets passed in, I can get a handle on my web context. I mentioned that this web context is the one that manages all of the other controls in my application. So part of this web context has a web query object. So calling the getWebQuery method on that web context will give me a handle on that web query object. And this web query object is the object that I'm going to use to query my data. Here I develop a where clause, which is just a string, where I want to find where the magnitude of my data is greater than the minimum magnitude variable, and where it's also less than the maximum magnitude. Using a predefined query criteria object, I set my where clause to that object. And now I'm all set with my query. But I also want to tell the map that I only want to filter, I only want to query my earthquakes layer. So I have some logic here using this web layer info object, and I can I basically loop through all of the layers in my map service, and once I find one that equals earthquake history, I could then add that to this cell layer object, which is just a list. So if I wanted, I could actually have searched multiple layers, but in this case, I only want to search one. Then on my web query object, which I got a handle on at the top of this method, I call the query method. And I pass in my predefined query criteria, which has that where clause, and also the list of my layer, my earthquake history layer. Right? So I get that back in the results object, which is just a Java util list object. And right before I highlight the objects in this list, I also clear any existing graphics that might have already been displayed. So I don't want to confuse the user having too much highlighted at once. And then I loop through this results object and highlight the geometry of that object. Right? And then so now all my objects which satisfy that query will then be highlighted in my map. You'll also notice here I've also provided another method called clear quakes. And since this takes a task event, then I know this is going to be another command. This is just a one-line code here where all I'm doing is clearing the graphics. So what I'm doing is I'm providing the user with another method to clear the graphics after they've created some within the graphics layer. So now I can save this code, and now I've written all the code I need in order to have this work in my task, in my application. But now I have two more steps I need to do. The next one is I have to add this as a managed bean in my faces config file. So my faces config file, that lives here in my web-inf directory, which is standard JSF development. And so if I open up my faces config file and I scroll down to the bottom, I'll see I'm going to add in another managed bean. I could have added this managed bean anywhere in this file, but I'm going to put it at the bottom just so I can find it easily later. So then I add in my managed bean. I'm going to call this Quake task. As I mentioned earlier, I could have called this anything I want, but I like to keep it the same name as my class so I know exactly which class this bean is associated with. Then I define the class as the class that I've just created, and I also define this with a session scope so that this task will be able to maintain the stateful changes of this task throughout my session. So that's the second step, of adding that as a managed bean. Right? Now I can come back to my map.jsp file and add in my custom task. I have a code snippet here which will allow me to easily write this, but using the IntelliSense, I could have done the same thing as I did for the table of contents. So we take a look at what this is doing. Is I have my task control, given a unique ID, in this case Quake, and here I assign its value attribute to the name of my managed bean, which represents my Java class. I also associate it with the map control of map1, and I also use windowing support as false, since I don't need this to open up in a new window. All I want to do is, because this is just going to display within a table data element in the table to the left of my map control. So I can save this, and then I can redeploy my JSP file right here within Eclipse. And now it's going to open up in another browser window. And as this application opens up, I should see the same application I saw before, but now I'll have a new item on the left-hand side. Here we can see it is the Quake task. So this Quake task was developed dynamically based on the code that I wrote within my Quake task Java class. So remember, I had two double variables, which were min magnitude and max magnitude. And since I used that camel case, it was able to split these into two different words. And I also have my two commands, which is my show quakes command and my clear quakes command. Right? Those came from the two methods that I wrote, taking those task events as parameters. So let me zoom in on the map a little bit. And now if I click my show quakes button, here I can highlight any quakes that satisfy that query. So if I happen to, so now I can change those to some other values. And when I click this again, we'll see that it shows up with different quakes. And remember, just before I highlight these new ones, I also clear any existing graphics that got displayed. So now that, so I don't want to confuse the user with having all of the ones I displayed. And then I can click this clear quakes button, and that will clear any of the highlights which are currently on my map. And it's simple as that. So I just had to create my Java code here, include it as a managed bean in my faces config file, and then add that as a control in my map.jsp file. All right. So we've just seen the process for adding this task by creating our own custom tasks using that task framework. Now we'll go to Satya for some more questions.
Thank you, Alan. We do have a lot of questions here. Tracy from Ashland has got a question on how are we running the demo application in Eclipse? Tracy, to answer your question, Eclipse has been, the version of Eclipse that we're using in this demo is 3.2, and we have the WTP extension installed, WTP 1.5. We also have Tomcat as our container to run these web applications configured with our Eclipse as IDE. The version of Tomcat we are using is 5.5.17. And also, in order to get the Eclipse running, we have installed the Java Runtime 1.5 and update 14. So let's move on to the next question. Many users have the same question as to what is the difference between a command and a tool. So a command is an element in our JSP page which actually triggers a server-side action without any further interaction from a client. So what is a good example is the zoom to full extent. So if you have a command zoom to full extent, and when you click on zoom to full extent, the map just zooms to the maximum extent possible. Whereas if you have a tool has two actions it has to perform. A tool has to first perform a client-side interaction, and then it is followed by a server-side interaction. So for example, the zoom in tool. So if you click on the zoom in, the tool is expecting a client-side action from the user as to draw or select a rectangle over the map. And once the user action or the client-side action is completed, the server-side action or the business logic in the server side is executed and the map is actually zoomed in. So let's move on to the next question. The next question is from Daniel from Miami. The question is, can the following setup be used? One SOM or SOC that is shared by .NET Web Server and the other by the Java Web Server. Let me rephrase the question. The question is, can I use one ArcGIS server setup with both the .NET ADF and the Java ADF? And the answer is yes. So Java ADF and the .NET ADF, you can use the same ArcGIS server instance behind the scene because remember that the Java ADF just connects to the resource that you are specifying in the web mapping application. So Louis from London has got this question on how do I create tools that are not in the manager? To answer your question, Louis, manager comes with some of the out-of-the-box tasks. So if you want to write your own task, or if you want to have tools and commands which is not given out of the box, the best way is to write a custom task which includes a set of tools and commands which satisfy your business requirement. Peter from Huntsville has got this question on what version of Eclipse and Sun Studio Creator is supported by the Web ADF. To answer your question, Peter, in the system requirements page of our support site, there's an extensive list of all the IDEs that is supported along with the version noted. To answer your question quickly, we do support Eclipse 3.2, and it can be used with the web tools platform that's a WTP 1.5. And a minimum Java JRE requirement to use Eclipse is JRE 5 with update 6. And for the Sun Java Studio Creator, we do support Sun Java Studio Creator 2 update 1, and it should have at a minimum of a Java Software Development Kit 5 with update 6. For more information on this, I would suggest you look at the system requirements, which is listed on our support services site. So moving on to the next question. Elaine from Boulder has got this interesting question that can JavaScripts be integrated into the custom applications built with the Java ADF? The answer is yes. The web ADF, the Java web ADF, it comes with the JavaScript libraries that is used both by the web mapping application and can be customized by the developer to put in your own custom functionality. A full API is available to customize this on our EDN site. You could also use your own custom JavaScripts along for other functionalities. So back to Alan.
Thank you, Satya. So, in this final section, we're going to see how we can handle results that get returned from some operation that the user performs. So while using the application, it's very common that some of the task operations will generate results that you want to display to the user. Examples are search results from search attributes task, address matches based on a geocode, or even geoprocessing results from a geoprocessing task. Obviously, these aren't the only type of results that can be returned, as results can be of any type, even Java objects that you've declared yourself. In order to make handling results easier, the ADF provides you with a web results object. This object accepts a list of results and will build the result display for you. As a developer, we have a lot of control over what information is shown to the user in the results display by using this web results object. You can specify the header that displays at the top, the text that represents the actual result in the list, the detailed information of the results, and what sort of actions can be performed on the results, such as zooming to or highlighting. So this web results object acts as a container for our list of result objects. It's declared as an attribute to the context, which is specified in the face-config file. By default, the results are displayed in a collapsible tree structure, just like the table of contents. So this web results object provides us with a method called addResultsWithActionArray. This is the method that handles the display properties that I discussed on the previous slide. Now let's take a closer look at how this method gets used. Here we can see an excerpt from the Java doc representing the required arguments for this method. On the right, we can see the final result of calling this method. Now let's go through each of these arguments to see how it affects the display at the right. The first parameter is a string parameter called groupHeader. This represents the text that displays at the top of the results tree. In this case, I've passed in identify results, so that displays at the top of my results tree, as shown by the red box on the right. The second argument is a Java util_list object that contains the list of arbitrary Java objects representing our results. In this case, it's a list of state objects in a list called resultsList. Then we have to provide a string that represents the method name on our object that we want to be called to display in the listing of results. Here I've passed in getStateName to get the name of the state as seen in a list as the name of Utah. The fourth argument is another string that represents the method to be called to get the result details of the object in the list. If you're customizing the web mapping application, these will be displayed in the result details panel. Clicking on another item in the results list will update the result details panel with the information of the new state. For this example, I've passed in getStateInfo to retrieve this information. And the final parameter of this method is a string array representing what types of operations you'd like to be performed on your results list when the user right-clicks an item. Here I'm passing in the options of zoom, highlight, and clear graphic, so when I right-click Utah, I can see these three options. Now let's take a look at how we code something like this. I'm going to come back into Eclipse. I'm going to clean up a little bit here. And if I take a look in my Java code, come down to the bottom, you'll notice I already have a results, which is a list. All right, so I can use this same results object and pass it in to this addResultsWithActionArray. So I have a code snippet again, which has some of the information here. And so here we can see this code snippet that was included in my Java code. Right? And again, I need to use Control-Shift-O so I can actually import this web results object into my Java class. Right? So what I'm doing is from my web context, which I already got a handle on at the top of this method, and then I get a handle on the web results object. And then using this web results object, I call the add results with action array method, and then I pass in query results, which will be the header for my results. And I pass in the list of results, which is the same. Let's take a bigger look at it. So it's the same results object that was returned from my web query, which I executed earlier. Then I have get name, which will get the name of that item in the results, and also get details, which will provide me with the ability to get the details for that item. And then the last item here is this string array, and I'm only passing in one item here, which is going to be zoom. So that when I right-click that item in my results display, I should be able to zoom to that. So now I save this, and then I redeploy within Eclipse. And now I open up in a new web browser again. I make this a little bigger so we can see it. And now here on the left-hand side, nothing looks different yet. I still see the same task as I saw in the last demo, but now the difference is that let me zoom in a little bit so I can actually see some of these. And then I click the Show Quakes button. I could show a few of them come up, but now instead of just highlighting them on the map, I can actually see I have a query results collapsible tree down here towards the bottom. And this returned 4 results which satisfied that query, right? And this was generated from that web results object using the add results with action array. Now if I click on any of these, down here at the bottom, it gives me the result details, right? So here I have this earthquake near Owens Valley, near Lone Pine, California, and has a magnitude of 7.75, right? So we can see that that satisfies the minimum and maximum magnitude variables that I declared in my task. And also, if I zoom into one of these, and if I right-click a different one and right-click zoom, it automatically brings me to that item. I can do that for some of the other ones as well. So just showing you how to take your list of task result objects and display the attribute data to your users by using the web results object. The method used to do this, remember, is the add results with action array method. Now we have some time for some final questions from Satya.
Thank you, Alan. So we have a list of questions here. And the first question is from Alex from New York. So his question is, what are all the out-of-the-box tasks? The best way, Alan or Alex, to see the out-of-the-box task is to go to your manager. When you're creating an application, it gives you a list of all the tasks available. Also, the ArcGIS Server Manager Help gives you all the tasks available, such as the editor task, the find address task, the find place task, the geoprocessing task, the query attributes task, and the search attributes task. However, remember that as shown in the previous demo, it is extremely easy using the task framework to write your own custom task. So the next question is from Arun from Brookings. So his question is, does one have to be an expert in JSF, that is Java Server Faces, to use the ADF controls? To answer your question, Arun, if you are using Manager to create our applications, Manager has been designed such that a non-developer, or you need not be a developer to create full-fledged web mapping applications using the Java Web ADF. However, if you are a developer and if you would like to customize the web applications further, you could use the templates to actually help you to give a jump start. If you are trying to build a complete web application using just the controls, you have extensive samples and documentation, and you could refer the API to use these controls. You need not be an expert in JSF to just use the controls and get the mapping application to work. So the next question is from Yuan from Salanti. And his question is, does ADF support Eclipse version 3.3? To answer your question, at 9.2, at version 9.2, the ArcGIS Java Server ADF only supports Eclipse 3.2 version. For more information on the supported IDEs and the exact version, I would again suggest you to look into the system requirements page listed on our support site, support.esri.com. We have time for one last question. Sean from Scottsdale has this question, or what other action method names are available to use? Let me rephrase the question. So when I click on the results and I get a context menu, so what are the options available, or what options are available out of the box for these action or context menus? The answer to that question is there are currently 3 options available. One is the zoom, the other one is the clear graphic, and the third one is highlight. Back to Alan.
Thank you, Satya. Before we go, I'd like to point you to a few resources. There are a couple useful instructor-led training classes that may help you learn more about ArcGIS Server. The Introduction to ArcGIS Server class is a 2-day class that serves as a good starting point for learning ArcGIS Server. It covers all the different types of services you can create, such as map, globe, geoprocessing, and geodata services, and how to use these within the out-of-the-box application. There are also sections on using the editing task and some options for customization. The Developing Applications with ArcGIS Server using the Java Platform class is a 3-day class which will take you into much more detail into the topics we've covered here, as well as exploring some of the various APIs that are available for you to write your Java applications with. There's also a free web training class called What's New in ArcGIS Server at 9.2 that will give you a good overview of the product. There are also many other free web classes available from our training site. Some of the online resources that will help you are the ESRI Developer Network site, or EDN as it's called. There is a Java Central section relating to all things Java. This is a public site, so you don't need to be a subscriber in order to access these resources. The ArcGIS Server Development blog is another good resource containing a lot of samples and tutorials. And the ArcGIS Server Help is also available online via the Web Help section of our website, so you can also find a lot of good information here. I'd also like to encourage all of you to please take a moment to complete our survey. Your comments will help us improve our future seminars. So to do so, just click the Give Us Feedback link to take the survey. We hope you've enjoyed today's seminar, and on behalf of ESRI, I'd like to thank you all for attending.